Postability's unified post kernel utilizes miscellaneous values to aid in customizing the output G code to suit your specific need. There are two miscellaneous values used. They are referred to as miscellaneous reals. These values can contain decimal numbers, and miscellaneous integers. These values must be whole numbers. These values are numbered from 1 to 10 starting from the top. Settings in the post overwrite the number system to reflect a naming structure that describes the value's purpose and valid inputs. These values will be used to pass information to the post processor about how the process should be output. We will look at each of these settings and their effects. Several values are not used as a default for all posts. However, your post may utilize these values. Refer to your specific post manual for explanation of those settings. Miscellaneous values not covered in this video are integers 1, 5, and 9, as well as reals 4, 5, and 6. Miscellaneous integer 2 is used to switch between absolute and incremental programming. A setting of 0 will output G-code in absolute, while 1 will output incremental. Operation 15 and 16 are identical and are drilling holes that are 1.5 inches away from the origin in X and Y. Posting op 15, which is using a setting of 0 for integer 2, shows output as expected, a G90 and position calls of plus or minus 1.5 inches. Posting op 16, which is using setting 1 for integer 2, shows an initial move done in G90. This first move for each axis must be done in absolute to position the tool to a known location. All subsequent moves will be done incrementally, as you can see with the G91 and 3-inch moves. Miscellaneous integer 3 is used to toggle 3D cutter compensation on or off. If this is a function you are interested in using, you will first need to confirm your controller is capable. Not all CNC controllers or Mastercam toolpath support this function. Operation 17 shows a 5-axis toolpath with this integer set to 0, so no 3D compensation is enabled. The code appears rather normal. Operation 18 has this setting at 1, which will turn 3D compensation on. Make note, some additional settings within the post may be needed. The resulting code will look much different. The output should contain the tool's position as well as the vector along which the compensation will be done. Miscellaneous integer 4 is used to select the tilting angle if two solutions are available. For example, operations 19 and 20 are identical and are set to cut a 20-degree chamfer along one edge, moving from the front face to the back face. Inputs for this integer are 0 for the positive tilt solution or 1 for the negative tilt solution. Op 19 is set to a positive tilt, while op 20 is set to a negative tilt. Running both of these paths through backplot, they look identical. But when run through simulation, the difference is obvious. Reviewing the G-code, we can see operation 19 is set to a tilt of positive 20 degrees and a rotation of 0, while operation 20 is set to a tilt of negative 20 with a rotation of 180. Miscellaneous integer 6 is used to change between feed rate outputs. Op 21 is set to 0, which will output feed in units per minute, and op 22 is set to 1, which will output in units per revolution. Posting both ops, you can see the difference within the canned cycles. The units per minute op shows an output with G94, so the resulting feed rate is 10 inches per minute. The units per revolution op shows an output of G95. The resulting feed rate here is 10 thou per revolution. Miscellaneous integers 7 and 8 perform similar tasks. They allow overrides of locking, breaking, or unlocking the rotary or tilt axes. The default value for both settings is 0, which allows the post to decide on the appropriate clamping method. However, if you want to override the post decision, you can do so here. In the example, ops 23 and 25 are set to 0 to allow the post to decide the output. Ops 24 and 26 are set to force a lock. Posting all 4 ops together, we can see the resulting change in the code. For op 23, we see an M11 and M13 posted prior to the cut. This has unlocked both the rotary and tilt axes. Moving down to op 24, we again see the unlock M codes, but this time we have forced a rotary lock and M12 is output prior to the cut. Op 25 is the same as 23, where just the 2 unlock codes are called, But looking at op 26, we see the M10 code to force the lock on the tilt axis. Options for this integer are 0 for post, 1 for lock, 2 for break, and 3 for off. Some controls may not support M codes for the breaking function. You may be limited to clamp and unclamp M codes only. Miscellaneous integer 10 can be used to output an M00 program pause before the current operation. A setting of 0 will not output an M00 and will instead leave the default M01 optional stop in place, while a setting of 1 will override the M01 with an M00. Keep in mind this M code will be placed before the current toolpath. For example, selecting ops 15 and 27, an M01 will be placed between the operations. Conversely, selecting ops 15 and 28, the M00 will now post out between the ops. Miscellaneous reals 1, 2, and 3 are used in conjunction to enable high-speed machining and output relevant variables depending on the machine or style of high-speed machining used. The example machine is a Haas mill, so only reels 1 and 2 are used. Here, reel 1 is used to set either a rough, medium, or finish cut, while reel 2 is used to set the max corner rounding size. With these values left at 0, no additional codes will be output, as is shown in op 29. The settings used in op 30 will generate the G187 smoothing settings code. These settings and resulting output will vary depending on the control and settings used. Consult your post documentation for further information. Miscellaneous reels 7 and 8 can be used to manipulate retracts. Reel 7 is used to manipulate retracts between operations using the same tool, and reel 8 is used to manipulate retracts within a single operation. Both have the same options for inputs. 0 for axis, which will retract the tool along the current tool's axis if supported by the control. If not supported, the post will interpret this as a 1. 1 will set the retract along a single axis, which for most machines will be Z, but some may use X. 2 will retract the same as 1, but will also add homing of the other two axes after. 3 will cancel any retract, even those the post has created, and use the clearance height. Examples for reel 7 can be seen by posting ops 31 and 32 together. These ops happen on opposite sides of the cube, and transitioning from one side to the other safely would require a retract. Setting reel 7 to 1 will allow the output of a retract between the operations even though the same tool is being used, which when posted can be seen in a G-code verify. This movement can also be demonstrated in a machine simulation. Once the left side operation is complete, the machine will retract before indexing to the right side for the next operation. Once the index is complete, the tool repositions for the next cut. If desired, the generated retract can be turned off by setting ops 32 reel 7 to 3. The resulting back-plotted G-code shows an index much closer, which may cause an issue. Running these settings through the machine simulation, it becomes apparent that not using a retract between these two operations will be an issue. Using just the clearance heights between indexes will result in a crash. This may not be the case for all operations using the same tool, and you will need to keep this in mind as, by default, the post will apply logic to determine when retracts are needed, but you can override where necessary with this miscellaneous value. Reel 8 behaves in the same manner, except it applies retracts within a single operation. Op 33 has machining on both sides of the cube within this one op. With reel 8 set at 3, you can see the lack of a retract between the sides of the part. Updating this value to 1 will output the retract call and avoid a crash. These settings can be seen in machine simulation as well. First, the resulting toolpath with the retract disabled by setting reel 8 to 3. The tool will crash into the part during this index to the second chain. With reel 8 set to 1, a retract is generated before the second chain is cut, avoiding the collision. These examples have shown cases where use of a retract before an index is preferred. It is likely that some situations would be more efficient without a retract. For example, if op 33 was only cutting one chain but was taking multiple depth cuts, using the default value of 1 for reel 8 would result in retracts between each step down. Setting this to 3 to cancel the retracts would result in a much more efficient toolpath. Miscellaneous reels 9 and 10 work together to manipulate the rotary axis output. Reel 9 specifies how the manipulation will be described. 1 allows a value to be input, and the value would then be input into reel 10. 2 sets the rotary position as close as possible to that of the last operation. 3 specifies the number of revolutions to adjust the starting value of the operation. The number of revolutions is then input into reel 10. 4 is used to allow the post to prompt for a value anytime a new chain, depth cut, or similar occurs. Op 34 can be used to demo this use. The current machine is limited to plus or minus 720 degrees in C, and the toolpath is attempting to do 3 complete revolutions about C. If the op is posted as is, it will have to unwind once reaching its max C value to complete the cut, as can be seen in the G-code backplot. The toolpath is doing less than 1 revolution after the unwind, so if we start the operation in a more negative C position, the entire path could be cut in one go. Set reel 9 to 3 for revolutions, and reel 10 to -1, so the path starts at negative 360 degrees from the current position. During the posting, there is no prompt about an unwinding occurring, and backplot confirms this. The toolpath now starts at negative 450 degrees, 360 degrees less than previous, and fits into the machine's limits for C.